Hello everyone, today I am going to present you our application, which is efficient database workload offloading Android application for wireless sensor network class. So what's our goals? We develop a mobile application for research information retrieval, utilize server DBMS and mobile DBMS at the same time, develop efficient offloading decision algorithm for mobile DBMS applications. So what's our application basically is we have two same database in mobile side and server side. So the user with our Android application, our application decides the query, predefined queries on execute on which platform. So in order to do that, we develop an algorithm and we use some formulas for that to decide the application execute the user query in it will decide to execute the query in the mobile side or server side based on the calculations. So basically we have huge database, like we have many tables and a lot of records. Then we have, as I said before, we have 10 queries, predefined queries, to measure which one is more efficient and which one is more faster to execute. Like this, we have 10 of them. So our decision, actually, besides developing application, we have our key part is offloading decision algorithm. So in order to apply this, we use some formula, and for step 1, actually we have 3 steps to imply that application. So before that, I need to tell you guys about the terms we are used. So what's PS and ES mean? PS mean is profiled query and profiled query in server side. ES means the execution time of the query and server side. So on the other hand, PM means profiled of the query in mobile side. EM means execution time of the query in mobile side. So we have this actually I had mentioned the n is the number of the query, for example 1 to 10. Then the I is stand for the how many execution happened in that for that query. So in step 2, we need to use the historical information about the query execution time. So in order to do that, we use real-time execution time informations and profiled informations, and we simply do some math to get the profiled information. But our main focus is in this calculations. We use exponentially weighted moving average, so which is very important for us. So we didn't just get the average of the historical data. We created and we search and spatial algorithm for that. So actually for the first query, as you see, mobile is much faster, and then for the initial condition we set the profiled information to get their values from the real-time execution values. But the second time we compare the profiled information and which one is more small, we use that site. In that case, we use mobile site because it's much faster than the server side, the query one. So again, but second times we started to make some calculations to get new profiled information. So in that case, for query 1, mobile side is apparently much faster than the server side, so our algorithms select the mobile side. Then the server side's profiled information remains same. So for the third step 3, we execute the query both side and update the profile in both sides if one has not executed in any queries beyond the threshold. So in order to just prevent execute our queries in one side, because one side can seem much faster all of the time, so we need to set threshold. So how we set a threshold? We actually use the profiled information for both server side and mobile side, and we use this formula to decide the threshold. So let me introduce our let me do our demo. As I said before, we have 10 predefined query, and our application will decide to run queries on mobile side or server side based on our algorithm. And our algorithm actually can understand and measure which platform going to execute the query, and because our algorithm can measure which one is going to be more faster and which one going to be more efficient for the our mobile phone. So on our code. So this is our application. Our application actually consisting of three parts, and application page is where we implement our application in application page, and evaluation for further development, and about page gives the general information about the team members. So let me do some demo with our application. So we can run the raw queries. So as I said before, we can calculate from server side and mobile side. As you see, it will give the result, and also mobile side. And as you see, it will give the execution times. In that case, server is slower than mobile. So we implement our algorithms in other queries. As I said, 10 predefined query. And for example, if we say select the query 4, and it will about to find all papers which published in a given organization. So for example, we can enter an organization name, Princeton. So we assume there's a event in Princeton University, and we want to get the information. So basically run the server, and as you see, our time is this for server side, and mobile side it's more efficient. So let me introduce our logic part, which is we implement our algorithm in here. So in first case, as I said, the execution times going to be set the profiled as unprofiled information. So based on the calculation, our application decide to set the threshold as a 10. So let me do other things. So execution number is increasing, and our application choose the mobile because the mobile site is for that query, mobile site is more efficient and more faster. It will be going to execute on mobile until the threshold. So when we come to the threshold, our application make calculations from both server and client, again based on the formulas. So in that case, it will based on this information, again mobile is much faster. So let me introduce other queries. For example, 7, find all other who published more than 10 papers. So from server side, it will take 239 minutes. So for mobile side, milliseconds. For mobile side, it will, as you see, take a lot of time. So as you see, there's a huge difference between the execution times between server side and mobile side. So in that case, when we click on the logic, it will basically select the server because going to select the server because server is much faster. As you see, the logic is select the server side, and because there's a very huge difference between between server and mobile, it will set threshold to the higher number, because this is apparent in this query. Server going to be always most of the time going to be almost always server is going to be much faster. So let me introduce another query. So for example, for number 9, find all the number of the published paper of each year. So from server side, 227 milliseconds. For mobile, as you see, almost 2 times. So for the logic, in this case, it will select the server. When we came to the threshold, it will apply our formula and our algorithm, and it will decide to execute the query based on this information. It will decide to execute the query on which platform. So the server is much apparent. So thank you for listening our application.